fireplace is back. Today I'd like to share with you the math joy that I've been having recently. So in the very first interview, Inna recommended the book by Paul Zeitz called The Art and Craft of Problem Solving. And I always thought that problem solving was not my thing because I was never into math Olympiads. So I hesitated trying out the book until recently. But boy, didn't I have the right problems, or maybe the right level of chilling and not worrying about the results and just enjoying the process of problem solving. Because within just a few days, the book, oh, where is the book? I had the book, wait. Within just a few days, the book became my Bible. I started the day with reading the book and I finally got the childhood I missed. And I couldn't recommend the book enough. The author puts so much thought and empathy into discussing the process of problem solving and even the psychological struggles of it that I really enjoyed it so much I had to put on alarms to stop reading the book. So I want to share with you 3 problems from the very beginning of the book to avoid the spoilers. And these problems might be called naive, but whatever, I thought they're still fun. But first, a warning. If you happen to be my colleague and feel the temptation to judge me, stop watching this video, close the window. You can even press the bell to unsubscribe. Here is the first problem. A monk climbs a mountain. He starts at 8 a.m. and reaches the summit at noon. He spends the night on the summit. The next morning, he leaves the summit at 8 a.m. and descends by the same route that he used the day before, reaching the bottom at noon. Prove that there is a time between 8 a.m. and noon at which the monk was at exactly the same spot on the mountain on both days. Notice that we do not specify anything about the speed that the monk travels. For example, he could stay still, travel backwards, whatever. And the monk does not have to travel at the same speed going up as going down. Now, I like this problem because it has a very simple solution, but the first second you see the statement, it looks kind of surprising, at least to me. So then when you figure out the solution, it still may stay a little surprising. While we are at the same page, here's the second problem. You're in the downstairs lobby of a house. There are 3 switches, all in the off position. Upstairs, there is a room with a light bulb that is turned off. One and only one of the 3 switches controls the bulb. You want to discover which switch controls the bulb, but you're only allowed to go upstairs once. How do you do it? No fancy strings, telescopes, etc. are allowed. You cannot see the upstairs room from downstairs. The light bulb is a standard 100-watt bulb. Now, I'm not sure I would put it in the book with math problems, but if you don't know the answer, it's very much fun to think about it, so enjoy. So here's the last one. It's a famous math problem, but I'd still like to include it because I like it. So it's in the bottom of the page. So I invite 10 couples to a party at my house, and I ask everyone present, including my wife, how many people they shook hands with. It turns out that everyone questioned, I didn't question myself, of course, shook hands with a different number of people. If we assume that no one shook hands with his or her partner, how many people did my wife shake hands with? I did not ask myself any questions. I remember seeing this problem some 15 years ago. And when I was a kid, I thought it was an impossible problem. And now, luckily, it all made sense, not in the way I expected though. And it's actually one of my favorite things in math, when some statement seems impossible at first glance, and then you have to get to the next layer or even 2 to see that it's actually possible and moreover even true. So have fun with and without math. Enjoy reading the Bible of problem solving, and I really hope to see you soon. And enjoy the fireplace.